Leslie has 25 cents in her pocket, but does not have a quarter. If you can tell her all possible combinations of coins she could have that add up to 25 cents, she will give you the 25 cents. Solve this problem before continuing. So my suggestion is read through the different ways that the students went about solving this and the different variations of their systematic list, because there are many, and we often talk about anticipating student misconceptions, and so it's good to look at some of the alternative approaches so that if you see an error, you might be able to probe them with some questions to help them self-correct. At any rate, there are a lot of different ways to do this. Most of them are going to involve freezing an entry in the list and working with all of the other possibilities in each row until you've exhausted all of them. So this idea of freezing means that you're holding one value steady while you manipulate the others, just to make sure that you are including all the possibilities in an organized fashion. I want to start with the biggest values. So we have dimes, nickels, and pennies are the only possible coins we could have. So I've labeled my table with those headings. And like I said, I'm going to start with dimes. You could for sure start with pennies. This is just the way that I would like to do it. So I could have 2 dimes, 1 nickel, 0 pennies. That adds up to 25 cents. I could have 2 dimes, 0 nickels, and 5 pennies. I could have 1 dime, 3 nickels, 0 pennies. I could have 1 dime, 2 nickels, 5 pennies. I could have 1 dime, 1 nickel, 10 pennies. I could have 1 dime, 0 nickels, and 15 pennies. So you see how we're freezing. We got all of our possibilities with the ones, all of our possibilities with the twos, and now we're going to consider alternatives when we have no dimes. So we could have no dimes, 5 nickels, 0 pennies, 0 dimes, 4 nickels, 5 pennies, 0 dimes, 3 nickels, 10 pennies, 0 dimes, 2 nickels, 15 pennies, 0 dimes, 1 nickel, 20 pennies, or 0 dimes, 0 nickels, and 25 pennies. So that attribute of freezing really helps us to maintain a system here in an organized fashion so that we can create a list to gather all of our possibilities. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possibilities. And now Leslie will give us her quarter. We must be really desperate for this 25 cents if we're willing to map such a problem out. But that is one way to use a systematic list in order to solve a problem.